Chris St. Clair, you're watching Viral Weather, a presentation of the Weather Network. We have talked about COVID-19. We've talked about mental health issues. We've talked about the origins of the disease. Today, we've assembled a panel including Neil Osborne, who is our senior climate editor here at the Weather Network. Also, we want to welcome to our panel Péter Molnar from the University of Toronto and Marta Shocket from UCLA. They're experts in their particular field, which is the transmission of diseases and parasites, which we'll get into. But Neil, I want to talk to you first of all, because the world's come together nicely to handle COVID-19. I mean, we've come together as a collected community. Does that help us with climate change in the future, do you think?
Chris, it's a really good point to make. Climate change is a difficult conversation for so many of us. And what I think we're quickly realizing and appreciating is a global community has come together to tackle this COVID-19. What would it look like if a global community tackled climate change in this capacity? I think the conversation about Corona, about COVID-19 is acting as if it's a test for what we could possibly do with climate change.
I mean, all of a sudden, the money's been there and the will has been there to do something. And climate change is one of those things that will present more challenges to us. And if we just go to the medical side of it, we look about the transmission of more diseases possibly in the future, right?
Yeah, and it's going to be so nice to hear some comments from our experts, Péter and Marta, today on this topic. Climate change has the potential to affect how these viruses and diseases are going to affect people. And in a warming planet, what does that effect look like? And so we need to spend some time particularly paying attention, I think, to the modeling of this. And so when we see intervention, when we see the opportunity to pay attention to the scientists, what they're telling us about the virus, what they're telling us about diseases around the world through the modeling, what would that look like if we paid attention more to the climate science and the climate modeling?
Well, let's talk about the modeling. We'll bring Péter and Marta in. You've been doing lots of modeling, both of you, but Péter in particular at University of Toronto.
And I think it's been quite striking how not only has the global community come together to tackle COVID, but also how we are all of a sudden, in my opinion anyways, paying more attention to what scientists are saying. All of a sudden, you turn on the TV and everybody's familiar with what a model looks like, what an epidemiological curve looks like, what R0 means, and all these things. And with climate change, it's been around for a lot longer, and in some sense, it's been more abstract in the heads of people. With COVID, within the matter of months and now within the matter of days, we can track the number of dead people, the number of infected cases, etc. on the web. With climate change, it's always been this thing that will at some point in the future come and hurt us. So for human nature, that's very difficult to deal with. And it's these long-term predictions that we have been making as modelers for 30 years, but I'm sort of expecting maybe as a fallout from this that will also become more widely accepted, more widely viewed in the general community.
It's interesting because when we talk about what we want to track, you and I were talking about this the other day. There's like 300,000 potential germs and viruses and parasites that are out there, and we can't track them all, can we?
That's correct. And so if anybody asks me what is going to happen with diseases under climate change, I think people sort of need to break this down into two different pieces. The first part is, what viruses or what bacteria, what fungi, what parasites in general do we even have to worry about? And like you say, there's not only gigantic number of species out there that haven't been studied yet. You just mentioned the number of 300,000 parasites. That's the number of species that we have for vertebrates. If you add viruses and bacteria, we're quickly in the millions. And we just don't have enough researchers to study every single one of those. Now you add to that potential viruses or bacteria, any other pathogens that we don't know of. Say the permafrost is melting, other things might be released into the environment. So the first question is, what are we actually even dealing with? Which of these many, many species will become the culprit that may cause the next COVID or something like that? And then the second question, I'm sure we're going to talk more about this as we go down the road, is if we have a suspected culprit, how do we actually make a model? How do we write down a prediction for those species and those pathogens, how they're reacting to temperature changes, changes in humidity, any other changes that we're imposing on the environment?
So we were talking about viruses in the future, Neil, and what it holds, and some examples and things we may learn from the past.
Yeah, Chris, this became so real to me. I was on assignment in the Democratic Republic of the Congo last year, and I had to go through an Ebola checkpoint. Let me tell you, Ebola becomes very real when you have to go through a checkpoint. And one of the things I think we're tackling with climate change that's a problem is it's hard to see climate change. And so as a photographer, I've had the good fortune of being on the front lines of witnessing, observing climate change. What's it look like for people around the world? And until it's in your backyard, like Corona is now, it's really hard to appreciate. And I know Marta has some speaking points to this as well.
Yeah, I think like you mentioned, this pandemic has a lot of reasons to give us hope because it shows that people can come together to make changes. But I think it also shows how hard it can be to think about how our actions now are having consequences for the future. So in this pandemic, the actions that we're taking right now, staying home, reducing the contact we have with other people, we don't see those consequences in the cases and the deaths until 2 or 3 weeks later. And for climate change, those consequences are even farther into the future. We're talking about years and decades, not just weeks. So I think climate change is in some ways a lot more challenging than this pandemic because we're having to make people think even farther into the future. But the fact that people are starting to do this for the pandemic does give some reasons to hope that they might be able to do so for climate change as well.
Well, you know, and let's just take an example because Neil had mentioned Ebola. And so your work has a lot to do with West Nile and studying mosquitoes. And there's some really interesting information about climate change and how that may have an impact on the mosquito population and the spread of disease, right?
Yeah, so my research is mostly on mosquito-borne diseases like West Nile disease. And climate has a really big impact, especially on mosquito-borne diseases, because mosquitoes are cold-blooded. So everything about how their biology works depends really strongly on temperature. And so one of the things we're noticing is that different species of mosquitoes are expanding their geographic ranges farther towards the poles. And we're also sometimes seeing mosquitoes becoming really numerous earlier in the spring and persisting later into the fall. And so when we have those big populations of mosquitoes for a longer time of the year and to a bigger geographic extent, we can expect that we might see more mosquito-borne diseases like West Nile virus.
But we were also interesting because mosquitoes, they have like a Goldilocks zone that they like to live in.
Yeah, so that's another one of our key points. Mosquitoes actually do best at kind of like a middle Goldilocks temperature. So it can also get too hot for mosquitoes. And so with climate change, what we really expect is not that mosquito-borne diseases are going to get worse everywhere. They're going to get worse in some places, but they also might actually get better in some places where it's currently really good for them. And with climate change, it will get too hot.
I ask a quick question because West Nile and Zika they're mosquito-borne, right? But they're different. Can you quickly explain that?
So Zika and West Nile are spread by different species of mosquitoes. So there's actually a quite tight evolutionary relationship between different viruses and different species of mosquitoes. And so West Nile has evolved specifically to be spread by a group of mosquitoes that are mostly in the genus Culex. whereas Zika is spread by a different group of mosquitoes that's mostly in the genus Aedes.
And West Nile is spread like from mosquitoes to people, but people can't give it to another person, right?
Yeah, so that's another interesting difference between Zika and West Nile virus. Zika and other related viruses can be spread from human to mosquito to another human, whereas West Nile virus is best spread in birds, but humans are what we call a dead-end host. So when humans get infected with West Nile virus, they can't really spread it to other humans because when mosquitoes bite an infected human, they're very unlikely to become infected with the virus. So almost all human cases of West Nile come from a mosquito that bit a bird and then bit a human.
Neil, we were talking about Zika, the relationship between Zika and West Nile. And when we think about climate change with this, it's so much of what's happening is based on modeling now, but it's important in the future too, right?
Yeah, you bet. I'm going to let Peter tackle this, but I was just reading an article the other day about yellow fever, and we traditionally thought of this disease as trapped within the Amazon basins. The other day I was reading that we're seeing this get closer to places like Sao Paulo and Rio de Janeiro, big cities. Peter, how do scientists make some sense of the geography, and the modeling?
Right, that's a very good question. And of course, there's a number of ways that we look at things. So I'm just going to break it down to a couple approaches. First things, like you basically put your finger on it. One way you can think of climate change is essentially weather patterns shifting around the planet to be what they were previously in a different area. So for example, I live in Toronto, and there's maps that you can look at that Toronto is probably going to become, in terms of climate, more like New York or Boston. A little bit more southern, a little bit more humid, etc. So then as a first pass, you might want to ask, well, what kind of diseases do they have down here? So that the environment is good enough for these diseases in New York and Boston, or in your case, down in the Amazon basins. If we get the same climate here, maybe it's reasonable to assume that we get similar pathogens. Now, that argument only goes so far. For example, you could think of Southern Europe, which is probably going to become in climate more like Northern Africa. And then you could again say, well, maybe we're going to get the same pathogens that they have there. But the problem is the pathogen also needs to get somewhere to this new place. In this example that I just gave, it needs to cross the ocean. So one other way that we can look at it is what we call mechanistic models, where we're essentially trying to represent the mechanisms that drive the disease and that determine, in case of COVID, how many people will fall sick, how many deaths will we have, etc. And then try to make some statements based on that, what will happen to the disease. In some sense, this is no different from a physical model. If you take a soccer ball and drop it 10 meters, then you can tell me that soccer ball is going to fall, and based on the laws of gravity, I can calculate how fast it will do that and all these other things. So we're trying to do very similar things with diseases. And so now we need to think about what are the mechanisms. Well, think again of COVID, for instance. We need to know something about how quickly is the disease transmitted. We need to know how high the mortality is, how many people will die from it, how many people will recover. All these numbers, that will determine ultimately how this epidemiological curve develops over time and whether or not we can flatten the curve. If we change the mechanisms by telling people to stay at home, we essentially reduce the transmission rate and we alter the disease dynamics. Now, when it comes to climate change, it's very similar ideas, but what we're asking now is how would, for instance, a change in temperature alter the transmission efficiency of a disease? Will it become more efficient or will it become less efficient? How will the mortality of any mosquitoes change that try to transmit the disease? How will their numbers change? And so, as you can tell, is in contrast to my example with the soccer ball, there's now a lot of complications that we need to think about. And part of it is the biology. How temperature sensitive are certain things? Are they going to get better or worse? And the other part is human behavior in it. How do we actually either react to such diseases, or how do we plan ahead of time and influence what will happen by doing so? And of course, that's in some sense up to all of us and to our politicians and leaders and what we do in our everyday lives.
There's a ton there, but what you're saying is that we're the ones who are moving the dangers around, by and large.
Well, I think that there's multiple angles you can look at that. First of all, we are responsible for climate change. So maybe whether or not we're directly responsible for the disease or indirectly is maybe even a moot point, but we do influence what's happening in ecosystems, and we are parts of ecosystems, so that affects us. We are also altering diseases simply by our behavior. The simplest one is we're flying around the planet and moving diseases around, which this particular thing does not have anything to do with temperature, but it does have to do with how populations grow, how many more people will start traveling, all these things. The other thing that you have to keep in mind, this whole idea of organisms having a Goldilocks set of temperatures, what that actually means from a climate change perspective.
Sure.
So I'm just going to give you an example. Think of a parasite that has a summer to develop from its larval stage to the time when it becomes infective to a human. I'm not going to specify which parasite because this argument applies to a lot of different things. And let's say that parasite currently requires something like 3 months to complete this task. That's when it will become infective to humans. Now you can imagine if the climate gets warmer, maybe summer gets longer. Now you have 4 months instead of 3 months. That makes it for the parasite easier to put in a full development and maybe even have a second generation of parasites. The other part that's really critical about this is that biological processes speed up with temperature. Every reaction happens faster, which means that if it's warmer, that parasite will now maybe not need 100 days, but only 50 days to develop. So now you have really quick development, and that means a lot of possibility for disease transmission. That would mean that that element of the disease system is sensitive to temperature in a way that would benefit the parasite and harm the host, which could be humans. But there is also the other effect of biological processes getting faster. If everything goes faster, you require more resources, your metabolism goes faster, you use them up faster, you use your resources up faster, which means that generally parasites don't live as long. If they don't live as long, we have fewer of those. Yes, they develop faster, but there's fewer of those. And as you see now, we have one positive effect of climate change and one negative effect of climate change.
Well, I want to go to our climate editor, Neil Osborne. We were talking about transmission of diseases. We're talking about how we've done a good job on kind of tamping down, at least in some places, COVID. But when you compare COVID with, say, Ebola, right, Neil? And that was 10 years ago, the outbreak in Africa, big difference.
Yeah, I just want to reiterate how real it became just last year when the outbreak happened in the Democratic Republic of Congo. And we were visiting mountain gorillas as part of a climate change assignment. And I was quite impressed with how quickly we were told and instructed to put on masks. And I think the point to make here is how important is a plan? You could argue some countries were slower to react than others, but at least from my perspective here in Toronto, my neighbors, we're staying at home. There's a plan. There's something very tangible we can do. We can stay at home. For climate change, that plan isn't so tangible, is it?
Well, Marta, because you got checked, right, for COVID?
Yeah, so about 3 weeks ago, I started showing symptoms of a lower respiratory infection, and I went to the local hospital, and I went through the process of trying to get tested, finding out that I didn't meet criteria, and then having some other tests to rule out other potentially bad problems, and then being told to just go home and self-isolate. And luckily, our area hasn't been super overrun here in the Bay Area, and the hospital seemed like they were able to handle everything that was going on. But of course, not every country and every community has those same resources. And that's leading to a lot of the disparities that we're seeing right now. And I think that's related to climate change too, because not every community has the same amount of resources to deal with climate change. And of course, disadvantaged communities are going to be affected by climate change more strongly.
No, that's an amazing point. I mean, because you look at how quickly we've here in the Western world been able to buckle down on this. But you look at places, you go through Africa, you go through a lot of the Indian subcontinent. There are many places where it's like a petri dish for this, right? And other diseases too.
Yeah. And getting back to having resources to tackle climate change, I think in North America, in the US and Canada, we have resources that in a lot of ways we just haven't chosen to use them yet. So for instance, here in North America, it's really hard for us academics to go to conferences without having to fly around, which is really carbon intensive. In Europe, I know there's a growing movement among academics to take the trains to conferences more because they have a better transit network over there. And one of the things that I've been doing to try and work on that in the US is encourage people to create more local conferences that are more focused on specific topics so we can present our research and accomplish a lot of our professional goals without having to use so many intensive carbon resources.
You know, Neil, we were talking about the COVID deaths, and it's been modeled how many people may die with COVID. Compare it to the people who die of respiratory problems every year because of air pollution. What's that number?
Yeah, I have to be careful here, Chris, too, and be very sensitive to who this is affecting right now. And, we have to pay our respects to all of the frontline workers day in and day out fighting Corona for us. The point that I think we have to also, just acknowledge at least, while being sensitive to the fight, the task at hand is the World Health Organization, for example, says there's upwards of 7 million people that are dying from air pollution. And so unless that air pollution is in your backyard, it's hard to find a way to relate to that and to connect to it. But if you've got a friend that's dealing with an ailment, whether it's from COVID or from air pollution, it becomes more real, it becomes more tangible, and you can act on it then. And so I think it might be fair to say what we're seeing in the response to the pandemic, I think this is almost a roadmap for tackling climate change. We're realizing policy can happen faster. We're realizing we've got access to budgets that we didn't know we had access to. And maybe the best part is it's bringing us all together again.
Well, I think that's really important. I mean, and we're finding new ways to do things that we used to do differently. So that might be the silver lining in this and the discussion it creates.
Chris, first of all, let's acknowledge that this is one of the most important narratives occurring on the planet, if not the most important narrative. And, the author Margaret Atwood said that it's not climate change, it's everything change. And so there's a misconception that climate change is only going to affect folks living on the coastlines. And we've got to quickly acknowledge that climate change is going to have an effect on all sorts of people. Think about folks who are currently dealing with mental illness and eco-anxiety. Think about the elderly. Think about the young with asthma and things like this, people like this. We've touched on the disadvantage, and I know our experts have some more thoughts on that as well.
First of all, I just wanted to bring our thoughts back to the idea of being disadvantaged. I think it's a general fact. Again, if we go back to COVID, if you are privileged, you are going to be dealing much more easily with whatever comes your way than if you aren't. if you have a nice big house in Toronto, it's very easy to self-isolate versus if you are living in a small condo, or even if you're homeless. With climate change, we have talked about Africa and India and tropical diseases that may or may not become more rampant. But I think it's also important to take a look north here in Canada, which is actually an area where we do quite a bit of research. If you look up to the Arctic archipelago, Victoria Island in particular, what we're seeing there is exactly the same things that we are expecting for tropical areas, but we're seeing them accelerated because the planet is warming faster near the poles than it is near the equator. And so we are seeing diseases is expanding their ranges northwards towards the pole. As it gets warmer, as it creates better conditions, the disease can get there. And so one example of that is a parasitic lungworm of muskoxen that, the average Torontonian will probably not think about very much. But it's actually quite a nice model system for looking at what climate change is doing. This particular parasite was only on the Canadian mainland up until 2008 or so, after which it jumped across the ocean channel onto Victoria Island and has been spreading northwards ever since. Now, what does that mean for the First Nations that live on Victoria Island? Well, now your muskoxen have an extra parasite. There's actually also a bacterium called Erysipelotrix, which has also invaded, also likely because it's now warm enough. And this is now causing declines in muskox populations. Some of these parasites might be killing the muskoxen. And even if it's not killing them, it's causing substandard meat. Now, if you're living up there, you're relying on hunting muskoxen and caribou and whatnot for your diet. So if these wildlife diseases start going north and start affecting, or are already affecting, essentially they're affecting the staple diet of humans in these areas, and that's gonna become a bigger problem as the area warms. And this is where it goes into how do the mechanisms that transmit this disease depend on temperature, and that will differ between different diseases. COVID's transmitted human to human, others are vector-borne, others are whatever. And so we have to look very specifically at the mechanisms for each disease to be able to write down predictive models for people to manage these diseases. So, that's just one example, but little things like that, we can come up with them in any area of the planet. Everything's changing, like you said.
Well, and Neil, that gets right into one of the most important things for everybody, and that's food security, right?
Yeah, Chris, one issue that we're going to face, as we tackle climate change, I think, and we should acknowledge how neat and how interesting it is to get this special access to scientists who can share their stories. And so I think part of this conversation also is about how do we share science in a more digestible and a more relatable manner. And so, at the heart of it is climate change needs a new story, right? Climate change needs to be told in more effective ways. We're seeing that it's about success. We're seeing it's about hope. And maybe you said this, there's a silver lining with COVID, and maybe we're appreciating what we're capable of doing.
We've talked about parasites and other viruses, West Nile, et cetera, but let's talk about just the impacts with COVID-19 and the environment.
We don't have a lot of data right now about how climate affects the transmission of COVID-19, but we do have a lot of data from other respiratory viruses. And so we can use that as a general lesson for how the climate affects respiratory viruses in general. And it seems like there's some pretty clear general trends. Unlike those other diseases that we've talked about that seem they're really sensitive to temperature, respiratory viruses seem like they're more sensitive to humidity. And instead of having a Goldilocks temperature where they seem to do best in the middle, for respiratory viruses, it seems like they actually do best at really low humidity and really high humidity. So that's why we often see influenza cases peaking in the winter in temperate areas when it's really dry. And we actually see influenza cases peaking when it's really wet in tropical areas. But in the coming years, maybe next summer, the summer after that, once more people have immunity and we have a vaccine, when COVID is established in the populations, we'll probably see patterns that are similar to flu, where it becomes really seasonal. But we can't rely on that right now. Transmission rates are just too high.
Yeah, Peter, you're nodding your head in agreement with all of this.
Well, Marta put it perfectly. I'm not sure whether I need to add anything to that.
Yeah, no, well, it's interesting because Weather Source is a weather network company, Neil, that's based in Boston, Massachusetts, and we have weather data for every single weather station all around the world for the past 20 years for every single hour of the day. So there is a treasure trove of weather data and climate data that's available to go to scientists like Peter and Marta who are working on this constantly, right? And there has to be some benefits to be found in there.
Yeah, I mean, the world over, we're getting excited about data because data tells us such fascinating stories. And so I think tackling COVID, tackling climate change, it's about making that data more accessible to people. And Weather Source is doing this, as I understand, in real time and making that data available so we can tackle COVID in more efficient ways. The hidden stories of data is a pretty interesting topic as well. And how can we extract those stories from the data, put them into these communication packages that people can better absorb, better digest. The stories of data, it's fascinating, really, isn't it?
Well, I mean, it's the basis of what both Marta and Peter, both of you are using, right, in your modeling.
Yeah, and it's been really interesting to see the scientific community tackle this. There's been so many different groups taking the publicly available data and building different models. And one of the things that's really helpful when we have multiple groups trying to take this data and build models is we can actually compare the different models to each other. And if all the models are saying really similar things, we can have higher confidence in what those predictions are going to be. And so that's been really great. I think this is one of the first challenges that we've faced in an era of big data and preprint publications. And so it's just been, a really exciting time for the scientific community to put some of these tools into action.
Peter, you were going to add?
Yeah, well, the only thing I was going to add to that is basically, in the beginning, you asked the questions about how we tackle climate change. And a lot of the information is already out there. If you talk to any scientist engaged in this, you can have a segment like this going for 2 days and they'll keep telling you new and new information. What's been lacking is making political decisions based on the evidence. And that's what I would like to see going forward, that we make our decisions based on the data and based on what those scientists that looked at the data days and months and years advise, that these data are telling us, that becomes a much more fundamental decision-making tool than we currently have. You see it in COVID. If you compare it between different countries, which countries are making decisions based on the data and which countries are making decisions based on the politicians' guts?
I have something I can
Sure
with that. In the United States, you can see there's been a lot of differences between the ways that different states have responded to the COVID pandemic, and even within states. So I split my time between the Bay Area and Southern California at UCLA, and there was a huge difference between the way that those two areas responded to the COVID pandemic. In Silicon Valley, the big tech employers and universities started mandating work from home much earlier than they did in Southern California. And I commuted down to LA one last time thinking that I would have 1 week at work. I didn't end up going into work, but you could see people were still going around business as usual in Los Angeles. And now that you look at the numbers, you can see that even though the Bay Area started out with more cases, it has way fewer cases than Southern California does right now.
Neil, that's a really good point from Marta about the difference, but I think that this whole COVID has offered us and is the beginning of a transition for all of us on the planet in a new direction.
Yeah, transition's the really interesting word there. And I heard this articulated in a really nice way the other day. The energy transition from wood to coal, and then the energy transition from coal to oil, that took decades. That took a really, really long time. What I think we're witnessing is that those transitions can happen faster. Could we leave oil behind perhaps and transition into cleaner energy faster? I think the response we're seeing to COVID is suggesting that we can.
I agree with you 100%. I mean, and this will be another podcast that we do and another special that we do about how fast we are starting to make a lot of these transitions and startlingly where they're occurring and how many people are already on board in a new direction. Listen, this has been terrific having you with us, Marta, in the San Francisco Bay Area, Peter at the University of Toronto in Toronto, and of course our senior climate editor, Neil Osborne, who will join us for more future episodes of Viral Weather, a presentation of the Weather Network.